Hello, this is the explanation point by point for the practice midterm exam. So we're gonna start. Let me just take this up. Okay, we're gonna start with question 1. In here, they're asking us to create a histogram to illustrate the distribution of age using the bins provided below. So in order to do this, what we had to do was we had to go to data and data analysis, and there is an option for histogram while selecting the variable age, that is the one that we want to get. And then I just input the values that I got in this table. Then I just selected the table, and that's how I got the histogram for this one. And I remove all the gaps. And then we have question 2. For this one, I use the count if formula. I just selected the whole city row. I named it city before. And I select the aspect that I wanted to count, that was Boston. And then I just select the whole table, avoiding the totals, in order to do this, to get the pie chart. Then we have question 3. We had to create a frequency table and a column chart to illustrate the number of customers across movie genders by gender. So we're analyzing 2 variables in here. To do this, we're gonna create a pivot table. We just go to data, select anywhere in the table, and then insert pivot table. And then it's gonna ask us to select which ones are the rows and the columns and the count of. So for count of, we're just use any aspect and change to count of. Then as it says in here, movie genders are supposed to be the rows and gender the columns. And then we just input the numbers from the pivot table here. Then let me move. There it is. Then they're asking us, if a customer who prefers sci-fi movie gender is randomly selected, what is the probability that the customer gender is male? So they are telling us, first of all, that we need to look in the aspect of sci-fi only, and then that the customer is gonna be male. So we're using sci-fi was a new aspect that they gave us. That's our total to analyze in the moment, and the probability of it being male. So we're gonna use, first of all, the 12 that is male over the total for sci-fi. And then they're asking us what percentage of customer in the sample are male. So in this case, they're not giving us any specific aspect. They're just telling us about the sample in general. So we're gonna use the total in here, and we're gonna use male over the total. And that's how we get it. And then in order to do this, we're just gonna use the whole table, avoiding the totals as well, and insert the bar table. Now for question 4, we have to construct a 90% interval for the average. This is the average that the customer spent. So we're gonna go here to the templates. In this case, they're asking for the confidence interval, and they are not telling us for the proportion. This is for the sample, and they are not telling us the standard deviation. So we're gonna use this one. We just copy and paste this in here. And now there is another template that we could use. I am not sure if that's gonna be a 11th exam in order to get this data. But what I did was that I selected the column for this column in here. I selected it all, and I went to data again, and to data analysis, and to descriptive statistics. And that's how I got what is in here. There's also different ways. So for example, you can just use the average function for this one, or you can also use a standard deviation and select the range as well. But this is how I did it in a more efficient way, I think. And then the sample size that we already know is 100. We can count that with counter function, but also we can just go to the end and see that it's at 101 minus the label. So we have that in here. We input all the data that they gave us, and that's how we get the result. This one we had already gotten it, so we just put the same numbers, and then the lower limit to upper limit, and the margin error. Then for part B, they're asking us to construct a 90% confidence interval for the proportion of over 137. So now we're going to confidence interval as well, but now for one proportion. And they're asking us for the number of successes. There are two ways to get this one. First of all is the count if, and we select the data, the range, and what we want to get, that is more than 137. Or what I also did was that I filtered the data here, and here they can let us filter for greater than, for example, and then I just put 137. And then I copy and paste the data I got from there in here. And then I use the counter function that also works just to make sure. And the data they already gave us, 90, the sample size 100, and that's how we get the numbers for these ones. Then for question 5, we have to create a box plot and compute the 5-number summary for the variable number of purchases. So there's another template that we could use for that, but I'm not sure if we can use it as well. So we can just use the formulas: minimum quartile inc with 1 if it is for first quartile, 3 if it is for third one, or 2 if it is for median, and the maximum as well. And then to create the box plot, we just have to select the whole row, that is number of purchases. And that's how we get it. And then we have to make sure that it's always inclusive median here. Now for sample size, they're asking how large a sample is needed to consider a 90% confidence interval for the mean number of purchases. If the desired error of estimation is 5% and the standard deviation is known to be approximately 11. So in this case, despite they're asking for a confidence interval, we're not looking for that. We're looking for the number, for the sample, how large the sample needs to be. So we go to the templates again, we're calculating sample size n, and this is not for the proportion, this is just for the sample that we get right now. So we'll click on calculating n for means, and we copy and paste that. Here is the confidence level as well, these are error and a standard deviation, and that's how we get the sample size. Now for question 6, we're gonna use the sample provided to do a hypothesis test to determine whether there is evidence of a difference in the average annual income for female and male customers. So we're analyzing in here 2 areas. First of all, we go to a hypothesis testing, and then we're analyzing 2 means, and they are not giving us for the standard deviation. So this is the one that we're gonna use right now. We copy and paste this one in here, and then we're gonna, in order to get this data, we did, here is asking us to create a pivot table. Once again, we go to data, we just click in anywhere in the table, and it's gonna allow us to select. In this case, I put in rows, I put female, male, and then in columns, the standard deviation of annual income, count of annual income, so we can have like a counter function, and then average of annual income. And now we are just gonna use the same information to complete this. In this case, we have to separate it. I separate it here better for female and male. And that's pretty much how we get all these numbers. The question was just asking us to verify if there was an option, a difference. So it's not asking us which one is more than anything. So this is not relevant. We're just gonna use this p-value. And in this case, there is no evidence of a difference in the average annual income because we failed to reject hypothesis null. So this one in here, and there is no evidence that there is a difference is anything other than 0. And then it was also asking us for a side-by-side box plot in here. What I did for this one was that I went directly to the table and I filter per gender. So I just click like female, apply filter, and then I copy and paste this row. So it's important to copy and paste in other place because in here, sometimes like if we just calculate directly from here, it's gonna be counting the in-betweens and we don't want that. So I copy and paste it in here. Yeah. That's how we got it. And then we select those two, and that's how we construct this one. Once again, we have to check that it is inclusive median, and that's how we got it. Then we have question 7. It's asking us to use count if formula and average if formula. For count if, we're just gonna use, well, first of all, it's asking us to analyze these two variables, average spend and movie gender. For count if, it's just movie gender. So we have the range that I had already selected before and named before, and the criteria that we're looking for. And then for average of dollars spent per movie gender, we're gonna use this formula. So we use the same range as before, as count if, the same criteria, but now we're gonna get the average of spend. Now we are gonna get, now for part B, it is asking us to conduct a hypothesis test to determine if there is evidence that the proportion of customers who prefer drama movies is greater than 54. So basically it's asking us if P is greater than 54. So in here we're gonna put 54 where we're trying to find if it is greater. The alpha that they give us 5%. Number of success, I use count if. So I just selected the number of people who chose drama. And then the sample size is 100 as always. So we're gonna use this P value. And there is no evidence at 5% significance level that the drama movies consumers is gonna be greater than 54. Now question 8, we're gonna use these two questions are asking us for normally distributed variable. So we're gonna use norm this and norm in. Norm in is usually to find the X value when given the probability to the right. So in this case, we have to input the opposite because we had just 5%, so we're using 0.95 as the probability. Then we use the mean that they already gave us, 114, and the standard deviation, and that's how we get the movie duration. Then for this one, we're gonna use norm this. This function is normally used to calculate the probability that a variable that is gonna be X in this case is gonna fall below at a specific value. So the specific, in this case, they're asking us if it's less than 1 hour, 1.5 hour. It's very important that we use the same measure for everything. So we're gonna be using minutes, and 1 hour and a half is 90 minutes. That's X. The mean that they gave us is standard deviation. And for community, we just click 1. Now for question 9, we have this table. We have to start by the first dollars that they are giving us. And the whole table starts with a 1 in here because this one is always gonna be 1. So first of all, they are telling us that plan A produces 61% of the components in total. So that's why we're putting 0.61, and then we can get the total of plan B by subtracting the other two. Now they're also telling us that 17% of the 61 that they created are defective. So we're gonna use this as a total, and we're gonna get the 17% of this. So that's times 0.17, and we get 0.10. And the rest we can get just by subtracting again. Same with the other one, they are telling us that the defective components of plan B is 7%. So that's what we get. And then we use sum to confirm. So what is the overall proportion of non-defective components? They're not asking here for anything in particular, just like the proportion, how many are non-defective. It will be 0.87, the proportion. And then in here, they're asking actually for the probability that a randomly selected component was produced at plan B, given that it is not defective. So first of all, probability is always going to involve division. And when they tell us giving that means that this is going to be our new total. So in this case, we use what we're trying to find, and that it was created in plan B. over the new total that is non-defective. And then finally, question 10 is just conceptual questions. Thank you so much.